Solving systems of equations by substitution. We already know that we can find the solution to a system of equations by graphing both equations and then seeing where their points intersect, or seeing where their lines intersect. But we can also solve and find that solution algebraically, and we don't need graph paper or rulers to do it. The substitution property of equality says when two quantities are equal, they can replace each other in any equation. So to apply that in example 1, this equation is solved for y. Y is all by itself. So if y equals negative 2x minus 2, that negative 2x minus 2 can replace the y in the other equation. So that looks like this. Negative 2x minus 2 equals negative 8x plus 4. When we have a variable on both sides, we want to get rid of one of them. So to do that, here I would pick on whichever one's smaller. That would be negative 8x. So I'm going to add 8x to both sides. This gives us 6x minus 2 equals 4. So now that I have just one x, I want to get that one alone. So I would add 2 to both sides and then divide both sides by 6. And we get x equals 1. Now we're also looking for the y value that goes with it. So our answer is an ordered pair. We have half of the pair. So I'm going to substitute 1 in for x, and I could use either of these equations, but I'm going to use that first equation and replace the x with 1. That gives us y equals negative 2 times 1 minus 2. Multiplying negative 2 times 1, we get negative 2. Negative 2 subtract 2 gives us negative 4. And make sure you write your answer as the ordered pair, putting your x value and then your y value in that order. In example 2, this first equation is solved for x. So x is all by itself. So we've got x equals 3y minus 9. So I'm going to take the 3y minus 9 and replace x with that expression. So first I like to go to this equation, negative 3y plus 3x, and I like to replace the x with parentheses. And then inside the parentheses, I put the expression 3y minus 9. To solve this equation, first we will distribute the 3. So I'll take 3 times 3y to get 9y, minus 3 times 9 to get 27. And then we would combine like terms. Negative 3y plus 9y gives us 6y. Then to solve for y, I would add 27 to both sides. And then lastly, divide both sides by 6, which gives us y equals 2. Now, we have half of our ordered pair. We have the y value. We still need to find the x value. So I will use this equation because I'm looking for x, and this equation is solved for x, has x by itself. So I'm going to take 2 and substitute that for y in this equation. So we'll get x equals 3 times 2, subtract 9. 3 times 2 gives us 6. 6 subtract 9 gives us negative 3. So our final answer is the ordered pair negative 3, 2. So even though we found y first, that doesn't mean we write it first in our ordered pair. Make sure you always write your ordered pairs x, then y. In example 3, this bottom equation is solved for y. So I'm going to take the expression that y equals and substitute it for y in that first equation. So first I would write this equation down, and in place of y, I would put parentheses. Then inside the parentheses, we put the negative 2x plus 17. Then distributing negative 1, that becomes plus 2x and then minus 17. Combine like terms, 2x plus 2x gives us 4x. 4x minus 17 equals 15. So then we would add 17 to both sides and divide both sides by 4. So x equals 8. So I would take the 8 and substitute it in for x into this equation that's solved for y. So we get y equals negative 2 times 8 plus 17. Negative 2 times 8 is negative 16. Negative 16 plus 17 is 1, so we get 8, 1.